Okay, welcome to the lecture number, I think 59. This is our lecture number 59. In this lecture number 59, we are going to do question number 5. Last time in last lecture, our lecture number 58, we finished till question number 4. Now I am going to do question number 5. Now please try to understand this question carefully. You will find two circles are given over here. Two circles are there. One with center A and other with center B. And you will find that the radius of the circle with center A is 4 cm. While the radius of circle with center B is 6 cm. And I have to get this length CD. I have to get length CD. So, in this case, I drop a perpendicular from point A on B. So, that is what I have written there. That draw AM perpendicular to D. Now, you will notice, dear students, this is 90. This is 90. Reason is what? Radius tangent. Reason is the same. Radius tangent. So by tangent radius there, you will get C as 90, D as 90, and M is 90 because we have drawn perpendicular. Therefore, quadrilateral C, A, and D becomes a rectangle. It becomes a rectangle because you will find all angles are of 90 degree. Of course, angle CAM also becomes 90 because if 3 of them are 90, the remaining one is obviously 90. So this quadrilateral becomes a rectangle. Opposite sides of rectangle are congruent. Therefore, AC is equal to MD, that is equal to 4. But total BD is 6. Total BD is 6. So we will be getting, if this is 4, then you will find this remaining is 2 because BD is a radius of larger circle. If this is 2, okay, then you will find circles are touching each other in point E. This is point E. Circles are touching each other externally in point E. Therefore, AB is equal to 4 plus 6, that is 10. That is 10. Then you can apply theorem of Pythagoras to triangle A and B. This is hypotenuse because it is opposite to 90. So you will be getting AB square, that is 10 square, minus 2 square, that is 4, 96. Square root of 96. Square root of 96. That is 4 root 6. So you will get M as 4 root 6. So CD is also 4 root 6 because M and CD are opposite sides of A, C, D, and. So this is how we have to solve it. Okay, now I am writing what I said. So you will find here, dear students, that here I am going to mention now quadrilateral. Okay, in quadrilateral A and DC, in quadrilateral. In quadrilateral AMDC, angle C is equal to angle D, that is equal to 90 degree, tangent radius 10. C is equal to D is equal to tangent radius 10. Angle N is equal to 90. Angle CAM is also 90. Remaining angle. Therefore, quadrilateral AM DC is a rectangle. Okay, please have a look here. Again, there is draw AN perpendicular to DB. Draw AN perpendicular to DB. Later on we will find in quadrilateral ANDC, C is equal to D and each one of them is 90, tangent radius there. Angle N is 90. Angle CAM is the remaining angle of quadrilateral, therefore it is also 90. So quadrilateral AMDC is a rectangle. If it is a rectangle, AC is equal to DM. AC is equal to DM. That is equal to 4 centimeters. Opposite sides of rectangle. Opposite sides of a rectangle. AC is equal to MB, that is equal to 4 opposite sides of rectangle. Then AB is equal to AE plus B. AB is equal to AE plus B. That is equal to A is 4, this is 6. 4 plus 6 is 10. AB is 10. Circles are touching. Circles are touching. External. AB is equal to A plus B. 4 plus 6, that is 10. So AB is equal to 10 centimeters. Clear all this? Now, as I explained you, I am going to apply theorem of Pythagoras. So in right angle triangle A and B, in right angle triangle, in a right angle triangle, A and B. In right angle triangle A and B, by theorem of Pythagoras. Triangle A and B is a right angle. And please try to understand that AB is hypotenuse because it is opposite to 90. Many students think the shape of this triangle and they presume that AM is hypotenuse, which is absolutely wrong. Because many students make a mistake of taking AM as generally you will find we always draw the triangle this way. But no, AM is not hypotenuse, but very important to understand. AB is a hypotenuse because which is opposite to 90. And then apply the theorem of Pythagoras. AB square is equal to AM square plus BM square. 4 plus 6, 10 square is equal to AB is given as 10. 10 square, that is equal to AM we don't know. So AM square as it is, plus BM is given as 2. So 100 Square of 10 is 100. Transfer to square, that is 4. That is equal to am square. 100 minus 4 is 96 is equal to am square. Root of 96 is equal to am. So we get it 16 6 that is equal to am. That is equal to am. AB is 10, 10 square is 100. 2 square is 4, 96 is equal to am square. Root of 96 is equal to am. 16 6 4 root 6 is equal to am. But am is equal to c opposite sides of rectangle. AM we got it as 4 root 6. Correct. But we find AM is congruent with CD. These are opposite sides of rectangle A and DC. Opposite sides of rectangle A and DC. Therefore, you will find M is equal to CD. That is equal to 4 root 6. Then C is equal to 4 root 6 centimeter. If unit is given, then we must write units. So this is how you will find this sum is there. Try to understand. Here, of course, units are given. 2 circles are there touching each other in point E externally. Then you will find that C is 90, D is 90, M is by construction is 90. So quadrilateral CAMD is a rectangle. So you will find AC is 4, therefore MD is also 4. But total BD is 6. So if we subtract 4, you will be getting BM as 2. So triangle AMB is a right angle triangle. AB square is equal to BM square plus AM square. 6 plus 4, that is 10 square is 100. 100 minus 4 is 96. Now we find root of 96. Root of 96 is 16 6 4 root 6. M is equal to 4 root 6. But M is equal to C. That is very important. AM is equal to CD. These are opposite sides of rectangle. And this is how we will be getting CD as 4 root 6. Many times this sum is asked in the examination. So please try to understand this sum carefully, because weightage is also 4 marks for this sum. So from examination point of view, this is very, very important. Now try to understand arc of a circle, concept of arc of a circle and central angle. Central angle and arc of a circle. These two are important concepts now. There, as well as there are 2 theorems are also there. After this, understanding this concept, there are 2 theorems also are there. And then we have to begin exercise. Two theorems are there. First of all, you try to understand the concept of central angle, major arc, minor arc. These all are very important concepts to understand. So first of all, central angle. you will find, if I draw some, if I take O as a center of the circle, now you will notice very important thing, that angle AOB is called as central angle. Reason is very simple, because vertex of the angle is at the center. Therefore, this is called as central angle. And measure of central angle is always equal to the intercepted arc. Intercepted arc is always arc which intersect means cut from front side. As well as you will find, this total arc is divided into two parts, this arc as well as this arc. Of course, you will find this is also called as intercepted arc, as well as the arc AXB is also called as intercepted arc. So you can say, if vertex of the angle is at the center, then angle is called as central angle. Arc AXB is called as intercepted arc by angle AOB. Angle AOB is equal to measure arc AX. This is very important reason. As far as central angle is concerned, it is very important to understand that measure of central angle is always equal to the measure of intercepted arc. If arc AXB is given as 30, then this angle is also 30. And sum of all angles at the center is always 360. So if I say this is 60, this is 60, and if I ask you what is the measure of this, your answer is 300, because this is 60, 60. Sum of all arcs of the circle is always 360. That is our next concept to understand. Arcs of a circle. Now, arcs of a circle. Again, if I take O as a center, if I draw a circle with center O, These are the different points. These are the different points I have taken on the circle. Now please try to understand. AB is called as arm, BC is also called as arm, CD is called as arm, B is called as arm, as well as AE is also called as arc of a circle. Now you will find, if I say arc ACE, try to understand. If I say RACE, which arc I say? AC. Now you will notice, dear students, arc ACE is greater than semicircle. This is semicircle. BCD is a semicircle. And if arc ACE is greater than semicircle, then naturally the arc which is greater than semicircle is called as major arc. Is called as major arc. So this is called as major arc. And the arc which is smaller, this arc which is smaller than semicircle, is called as minor arc. The arc which is smaller than semicircle is called as minor arc. So you can say, first of all, major arc. Arc of a circle greater than semicircle is called as arc of a circle which is greater than semicircle is called as major arc. RACE. RACE is major arc. Next concept is minor arc. Minor arc of a circle, arc of a circle smaller than semicircle is called as arc of a circle smaller than semicircle is called as minor arc. Arc AE, or better we call AXE. Arc AXE is minor arc. Try to understand the concept of major arc and minor arc. The arc which is greater than semicircle. Of course, semicircle is this much or this much. But you will notice this arc is greater than semicircle. It's called as major arc. While the arc is smaller than semicircle, it's called as minor arc. Very important. The next concept is sum of all arcs of a circle. Central angle also it is easy to understand central angle. Next concept is sum of all arcs of a circle. Sum means addition of all arcs of a circle is always 360. Now you can begin from any point. Supposing if I begin from point A, and if I go on adding the arcs, and if I reach at point A, the sum of all arcs is 360. For example, measure arc AB plus measure arc BC plus measure arc CD plus measure arc CD, then D plus measure arc EXA, that is equal to 360. I begin from point A and I reach at the point A. AB plus BC plus C plus D plus EX, and I reach again at point A. So sum of all these arcs is always 360. So this way you must have to learn addition of the arcs also, how their additions are taking place and how we are getting the answer. The next is theorem on page number 68. Page number 61. Theorem on page number 61. I'm going to explain it again now. Hope that this is very clear to you. How to get the sum of the arcs. RAC is a minor arc, less than same circle. RADE is a major arc, or RADE also you can call. You may call RABE also. You may call it as RACE. These all are same arcs. Only the beginning point and end point should be the same. Theorem is that theorem which is here, there are two theorems, but I think we will be able to finish only one theorem on page number 61. Page 61. .2 is over. Okay, page 61. Theorem. The chords corresponding to the congruent arcs. The chords. This is a statement. The chords corresponding to congruent arcs corresponding to congruent arcs. Of course, of circle are congruent. So we find here figure is given. B is given as a center of the circle. So B is the center of a circle. AC and DE are two chords. AC and DE are two chords. The chords corresponding to the congruent arcs. Let's join this. This is how you will find we get two triangles will get. Here we have to take point E and Q. Okay. Now what is given? Please try to understand. Given is given is equal to RKPC is congruent with RKBC is equal to this APC is congruent with EQD. Okay, DQE. To prove that chord AC is congruent with chord DE. They have given us theorem in fill in the blank type, but I prefer to write this theorem. Okay. Now you will find the chords corresponding to the congruent arcs. If you consider this beginning part only, then you will find RAPC and REQD are congruent arcs. They are intersected by chord AC and chord DE, and therefore we have to prove that corresponding chords of congruent arcs are also congruent. This D is congruent with AC. Rest of the part is very easy. Try to understand. These are congruent arcs and we have to prove AC is equal to D. Okay. Now I am going to prove these two triangles congruent very easily, because these are the sides of these two triangles. So these two triangles. So proof. Please try to understand the proof carefully. In triangle ABC, and triangle ABC, I'll say DB, triangle ABC and triangle DB. Clear? Then you will be getting AB is equal to DB. AB is congruent to DB. AB and DB, if you will notice, they are radii of same circle. They are the radii of same circle. Please try to understand. These two are the radii of the same circle. Because AB is also radius, DB is also radius. Now please try to understand. This is very important. Angle ABC. Okay, if I take this. Angle ABC, very important. Angle ABC is congruent to angle. Angle ABC is congruent to angle DBE. Why? Central angles of arcs ABC and arc DQE. These are corresponding central angles. If arcs are congruent, corresponding central angles are congruent. If angles are congruent, corresponding arcs are also congruent. That is a property of central angle. Very, very important. So you will be getting angle ABC is equal to this. This is very important. So next to that is BC congruent to DB. BC congruent to DB. Same reason, radii of same circle. Radii of same circle. BC is equal to DB. Radii of same circle. Try to understand again. AB is equal to DB. Radii of same circle. Angle ABC is a central angle corresponding to arc APC, and angle DBE is central angle corresponding to arc DQE. If arcs are congruent, the corresponding central angles are congruent. Very, very important concept. The next part is easy. BC is congruent with BE, radii of same circle, and then triangle ABC is congruent to triangle DBE by SASS. By SASS. Two sides angle included by them. Two congruent sides angle included by them. Therefore, these two triangles are congruent by SS test. Therefore, AC congruent with DB. AC congruent with DB. Corresponding sides of congruent triangles. This is our chord AD. Chord AC congruent to chord DB. Please try to understand this theorem again. I am going to revise it quickly. The chords corresponding to the congruent arcs are congruent. Fine. So APC and DQE are given congruent arcs, but these arcs are intersected by chord AC and D, and hence we have to prove AC is congruent with D. So given arc APC is congruent with arc DQ, to prove that AC congruent to D, in triangle ABC and in triangle DB, these two triangles, AB congruent to DB, radii of the same circle. Angle ABC congruent with angle DBE, these are corresponding central angles of the congruent arcs. Therefore, these two angles are congruent. Next to that, BC is congruent to B. BC is congruent to B. Reason being that they are also radii of the same circle. Therefore, triangle ABC congruent with triangle DBE by side angle side angle side test, and hence you will be getting AC congruent with DB, CS, CT corresponding sides of congruent triangles, and therefore chord AC is congruent to chord DB. That is what we have to do. So here we will find we finished a very important theorem as well as exercise 3.2 also we have finished. Now next time we will do one more theorem, or even though you can call it as converse of this theorem. Then we will begin in the next lecture. Practice set 3.3 will begin. So this is how you will find more or less they have finished the required sums. Dear students, the circle is very important chapter. Why I have noticed that even in the similarity in the theorem of Pythagoras, I am using scale or instruments to draw these figures. So if you will draw with the all geometrical instruments, surely there will be a neatness in your notebooks. You will surely like to read it. So I would like to request you, avoid drawing with freehand drawing. Use the instruments and draw very good figures. Write the way I have written, given, underline that, to prove that, because these all things matters. That is what my teachers taught me. So I am also telling you the same things. Even you will notice one thing, that is sign should come one below the other. That much precautions we have to take. Also, give support to all statements. Reasons we have to. These all are very important things in while studying. When we say study, and we study for ourselves, not for examination. Okay. Thanks a lot for listening this lecture number 59 carefully, as well as please revise this video again and again. God bless you all. Thank you very much, dear students. Thank you.